Good morning, children. In today's class we are going to see why for obtaining inverse of a matrix a particular equation for row operations or a particular matrix equation for column operations is used. So for this, let us first of all consider a matrix equation of this kind. Now for here convenience sake I am taking here all these three matrices to be square matrices of order 2. You can take any example where the multiplication of matrix is possible. So here let us take matrix B to be the matrix with elements 1, 2, 3, 4. A matrix C with these elements, and let's find out the product here that will give us matrix A. So we'll have 1 minus 2 minus 1. This is also minus 1. Here is 2 and 4. So the product matrix has been obtained. Now let us apply a simple row operation. Suppose I want to make a change in row 1 as R1 plus R2. Now to apply this row operation, there are three possible cases. The first case, we can apply the row operation on matrix A and matrix B only. A second case, we can apply row operation on matrix A and matrix C. And there is also a third possibility to apply the row operation on all the three matrices A, B and C. So let's perform these operations one by one and see what results do we get. So this is a basic matrix equation. We want to apply the operation on matrix A and matrix B. So applying the operation on matrix A, row 2 is same. R1 plus R2 gives us minus 2, 6. On the right side, this is matrix B, so we are making changes only in the matrix B. So that's 4, 6, and matrix C does not change. In this case, the row operation is applied on matrix A, so we obtain this. The operation is not performed on matrix B. It is performed on matrix C. So it is 0, 1. In this operation, it is applied on all the three matrices. So the result that we get is matrix B is 4, 6, 3, 4. Matrix C is 0, 1, minus 1, 1. This way. Now in all the three cases, let us find out the product of these two matrices. So the product would be 4 minus 6 minus 2, 3 minus 4 minus 1. This is 6 and this is 4. Likewise, let's find this product again. So it is 1, 0 minus 2, this is minus 4, and 1 plus 2, 3, this is 3 plus 4, 7. On the right hand side, multiplying these two, the product matrix which is obtained is minus 6, minus 4, and here is 3 plus 4, 7, 4 plus 6, this element is 10, and 3 plus 4, 7 is here. Now in these three cases, you notice that in the first situation, the matrix that is written here, that is the new matrix A, is the same as this product matrix. In the second situation, the matrix here and the matrix here do not match. This matrix is not equal to this matrix. This is what I mean by putting this inequality sign. Likewise here, this matrix and the matrix obtained after finding the products do not match. What this means is that these are the wrong row operations used. Which is the correct row operation? The first one. What is special in this? If you notice, our equation is A is equal to BC. When we apply a row operation, the row operation is to be applied on matrix A, the single matrix on left hand side, and on the right side we have product of two matrices. The operation is applied on the first matrix here. Matrix equation is this. We perform operation here and here, row operations. If you remember, we had written this equation for you finding out using the row operations to find out the inverse of the matrix. Here you can see if you make changes here and here, only then the equation is a valid equation, right? So now we understand why we use this particular equation for performing row operation. In case we perform a row operation on this matrix and this matrix, it simply leads us to equality of matrices but does not help us to find out the inverse of the matrix. Now, to perform the column operations, the matrix equation is A is equal to BC, and let us take matrix B to be 1, 2, 3, 4. Matrix C is suppose 2, 1, 0, minus 1, and the product is 2, here it is 6, the next is 1 minus 2, then here it is 3 minus 4. This is the product matrix. Now suppose we want to perform this column operation here. So again there are three cases possible. Apply column operation on matrix A and B only. Second case, apply column operation on matrix A and C only. And the third case, apply column operation on all the three matrices. So here, matrix A, this is second column. The first column elements are this. Performing the operation on matrix B, and matrix C is the same. Here applying operation on matrix A, matrix B is the initial matrix. Performing the operation on matrix C, second column is this, and the first column is 3 minus 1. And likewise over here, after applying operation on matrix A, we obtain this. The new matrix B is this matrix, and matrix C is 3, 1, minus 1, 1. Let us find out this product now. So the product is 6. This product next is 14, 3 minus 2, 1, 7 minus 4, 3. Over here it is 3 minus 2, 1, 9 minus 4, 5, then 1 minus 2, minus 1, 3 minus 4, minus 1. And on the right side here, this is 9 minus 2, 7, 21 minus 4, 17. This is 3 minus 2, 1, 7 minus 4, 3. So here also you can see that in the first case, the matrix A is not equal to the product matrix. So this operation is not a valid. The operation is valid, but it does not apply in this way. Here you can see the matrix A and the product matrix are the same. In this case also, the matrix A and the product matrix are not equal. So what we get to know here is that although the operation is a valid operation, but it is not applicable in the first case and it is not applicable in the third case. So where is it applicable? Here. In this case, what have we done? Perform the operation on A and C. Now if you look into this equation, we are performing the operation on this matrix and on the second matrix on the right hand side. For the column operations, we were using a matrix equation of this kind. So now I think it is very clear that you make changes here and in the second matrix. So this is the equation used for column operations. Now based on this concept, we are usually asked a 1-mark question in the exam. What kind of a question is this? Let's see. So the question in the exam can be, apply R1 as R1 plus R2 in the following matrix equation. Second question can be, apply the operation C1 plus C2 in the following matrix equation. And the equation I am taking the same. So these are questions of 1 mark usually asked in the board exam. So if we get this equation, then understand this is an equation of the kind A is equal to BC. You need to apply row operation. So what should you do? Apply row operation in matrix A and in matrix B only. So when you apply the operation, what do you get? R1 plus R2, so this is 8 minus 2, and here you get 6 minus 1. Matrix B, R1 is 4, 6, R2 is 3, 4. There is no change in the matrix C. So this is your final result. Now you don't need to multiply this and show that it is equal to this. So when a question of this kind comes, you should know what kind of matrix equation is given and in which matrix do we need to apply the row operation. Likewise, this is again a 1-mark question, apply column operation. You can see here the matrix equation is again A is equal to BC types. So where will you apply column operation? In matrix A and C. So apply the column operation. You get 1, 5, minus 1, minus 1. Matrix B remains unchanged. Here adding this way. So this is a final result. Here once again we will not find out the product. So these are 1-mark questions simply to check whether you have understood the concept of matrix multiplication along with the usage of row operations and column operations. So with this we end today's class, and in the next class we shall be solving some questions from the miscellaneous exercise of the NCERT textbook.